Hello everybody, welcome to Dr.K.Liu Maths channel. This question is from DSE M2, a sketching problem. A typical sketching problem. Let's look at this one. And given a function fx equal to 3 times x to the power 3 over x squared minus 12, where x is not equal to positive and negative 2 times root 3. Of course, it is because that these 2 points are when the asymptote is occurring. And y, they look the curve for y by h, prove that the second derivative of fx is equal to this one. Okay, I think it's better to do the first derivative. That's just by formula x squared minus 12 times the derivative of the power the numerator is line x squared minus 3 times x to the power 3 times the derivative of the denominator is 2x over over x squared minus 12 all square, and simplify this format. We got the answer here is 3x squared times x minus 6 times x plus 6. Because I have to do one more differentiation, therefore I expand the numerator for easy differentiation. 3 times x to the power 4 minus 36 square, 36 times x squared over x squared minus 12 over 2 to the power 2. And then for the second derivative, then I keep the 3 outside, and for the denominator times the numerator 4x times 4 times x to the power 3 minus 7 to x minus x to the power 4 minus 36 times x squared times 2 times x squared minus 12, then times 2x. For the denominator is x squared minus 12 to the power 4. And here we can cancel 1 x squared minus 12. That is the denominator is to the power 3. And this is low, that this term is cancelled. Okay, then I think it is better to simplify the denominator and numerator. Denominator is keep as the original format, and for the numerator I finally calculate the format of this one. Here I skip that step for the detail. The detail step I skip here. Guys, you can try by yourself, so that you can look. What is this? Okay, yes, it's right. So great. Okay, and for second part and the third part, part B and part C is finding the turning point. Turning point means maximum minimum, and part C is point of inflection. Therefore, I have to set first derivative equal to 0. First derivative equal to 0, that is 0, 6, and minus 6. And also, x is not equal to positive and negative 2 times root 3. And when set the second derivative equal to 0, we have x equal to 0 and x is not equal to 2 times root 3. Okay, here although the question only in part B we find the turning point, and in part C we find the point of inflection. I think it is better to combine the table because we have for easy sketching. Okay, here x and so many points here. X negative 6 less than negative 6 and negative 6 between negative 6 and negative 2 times root 3, and between negative 2 times root 3 and 0, and between 0 and 2 times root 3, and between 2 root 3 and 6, and final is x greater than 6. The first line is the first derivative. The second row is the second derivative. It should be the second row. Second row is first derivative. The third row is second derivative. And the third row is fx here. Okay, I put value to test the. I mark that first derivative here. F pi x equal to 3 times x to the power 4 minus 36 x squared over x squared minus 12 to the power 2. Okay, and when x less than 6, this is, of course, I can use my calculator. It is positive, and then negative, and then negative, and then negative, and then negative, and then positive. Oh, so great. You can actually you can do it. You can do it easily. But anyway, if you have time, you can do it yourself. Okay, for the second derivative derivative, this one, and only change sign is 0, and also this part positive and negative root 3 here. I finally got the change sign here. Therefore, the shape of the function should be in this part. And when x less than 6, negative 6 is increasing and concave downward. And between negative 6 and negative 2 root 3 is decreasing and concave downward. And in this range is decreasing and concave upward, like that, and this is decreasing concave upward. Therefore, this is point of inflection here. 0 is point of inflection here, and negative 6 is maximum. Okay, then here is decreasing concave upward, increasing concave upward. This is maximum. This is minimum. This pi, point of inflection, and these 2 points is asymptote when asymptote are here. Therefore, in part B, there is 2 turning point. One is maximum point, negative 6, and put to the function is negative 26, and maximum point, and this is this is the second one is minimum. Minimum point is 6 and 27. And for part C, the point of inflection should be pi. Pi is 0. Only one pi, as the value of y is 0. And finally, I have to mark the asymptote here. From the function, we can see that the 2 vertical asymptote. Which is x equal to 2 root 3 and x equal to negative 2 root 3. And also by long division, I use long division here to calculate the asymptote here. This is 3x cubed minus 36x. This is 36x. Therefore, the fx should be written as 3x plus 36 x over x squared minus 12. Therefore, oblique R 就唔同，should be y equal to 3x. Okay. Let's start the drawing here, the sketching for final part. Final part is E. It's so great. It's not simple question here. Very long question. Okay. First, I draw the R 就唔同。Oh shit. R 就唔同 here. There's two R 就唔同。There's two vertical R 就唔同 which is negative 2 root 3 and positive 2 root 3. And also one R 就唔同 is y equal to 3x. And then the next step is draw the maximum point, minimum point. The maximum point is negative 6, negative 27. That is from the graph here. The shape of the graph should be like that. But in both sides, we have two R 就唔同 two. We have to show that the curve is tends to the straight line. These two straight lines are 就唔同. And for the maximum point here, the minimum point is 6. 27. There are also two R 就唔同 for this one. You can see that the shape is same. Okay. For the middle part, which is like that. That is a graph of this function. Okay, so it is pretty long, but anyway, I hope guys can enjoy this video, and if you found Dr.K.Liu Math channel is useful, please subscribe my channel. Bye bye.